Welcome to Public Finance. This is a lecture on measuring social benefit, and we're going to focus on a graphical presentation. So let's get started. Uh, so in this presentation, what we're focusing on is what we would call an operational measurement with transferable utility and rational agents. That's to be technical. It's operational in the sense that we're not just talking about conceptual ideas of how to measure welfare, but we're going to talk about the theory of how to actually implement um, some ideas that are related to some broader theoretical concepts of agents' welfare, like Pareto efficiency. And in particular, we want to do a very quick focus on just two ideas and the relationship between them. Um, we're going to be talking about total social benefit and marginal social benefit. A quick reminder, this counts as a transferable utility situation because we're dealing with people in an economy where there's money and we can measure the benefits in terms of money directly instead of in terms of their utility. And because we're assuming that there's money in the economy, that also implies that the benefits can be transferred between the individuals. Notice also, and we'll pick up on this topic later, we're ignoring costs. And you might ask yourself, why are we ignoring costs? And we're ignoring costs because we want to make sure that we give a clear presentation of how to measure benefits. So the way to think about things for the moment is that there's some goods in the economy and we're assuming that they're delivered by some otherworldly um, entity. And the only question we would have if we had different wants and different potential goods that this otherworldly entity could deliver is which ones should they deliver? And if there was some trade-off between them, that they might be able to deliver one item in a certain quantity, like tires, and there's a trade-off between that good and some other good, like cell phones. How would we, um, using the theory of welfare measurement, tell that otherworldly entity which goods we would more prefer to have? And the answer is really clear, that we would just want to maximize the total benefit from any deliveries that they made. Be a little bit more concrete. And if you look at the graph in front of you, you'll see that there's a downward sloping green line that's labeled with marginal social benefit. And then on the horizontal axis, the good in question is donuts. And I've marked off two quantities, 10 donuts and 11 donuts. And then you can see there's a trapezoid that is striped green and black. And that area, the area of that trapezoid, measures the additional benefit, or what we call the marginal benefit, of moving from 10 to 11 donuts. So that's the marginal benefit of the 11th donut. And if we measure that area and we're careful about it, if you look at the formula on the screen for the area of the trapezoid, we would be measuring one length, which is the height at 11, and another length, which is a height at 10. And so I've given those two lengths of the trapezoid sides as $23 and $23.50. And we're measuring all of our units for benefits in terms of dollars, as is typical in most applications that you see. And so the average of those two bases is $23 and $23.50 added together and divided by 2. The average of those bases would be $23.25. And then we would multiply it by the height of the trapezoid, which is just the distance between 10 and 11, which is 1. So we can see that the area of that striped trapezoid is $23.25. And then notice I've put down that that's approximately equal to $23, which is just the height of the marginal social benefit curve at the quantity 11. So what happens in practice in most applications is that we simply look at the quantity on the horizontal axis and then read off what the height of the marginal social benefit curve is and say the marginal social benefit of the, for example, the 11th unit or the 11th donut is $23. And we don't bother going through the trouble of formally calculating the area of the trapezoid. But if we were going to be technically correct and say that we're measuring the additional benefit of a whole donut, that would be moving from 10 to 11, and we should measure that whole area. But in practice, we just say the marginal social benefit of the 11th donut is $23. So now we want to talk about the relationship between total social benefit and marginal social benefit. Marginal social benefit, um, again, is synonymous with the idea of additional social benefit. So if we think about adding up the additional benefit of all the units that we've received, then we would get a total sum. So of all the benefits. So the total social benefit is the sum of the marginal benefits of all the units that we're talking about within our total. So the first equation that you see simply says that total social benefit is the sum, and so we have the capital Greek letter sigma there, and an index I is equal to 0 to 5, and then we have marginal social benefit of the ith unit on the right-hand side of the equation. And so that's simply the marginal social benefit of the first, the second, the third, the fourth, and the fifth donut in this case. And one other thing that is a connection in terms of language that we'd like to identify is that benefits that people report in these types of environments are normally reported in terms of their willingness to pay. So if we assume there's just one individual and we were to ask, well, how much is that individual willing to pay to consume the 5 donuts, then we would say, well, their total benefit, the sum of their marginal benefits for those 5 units is going to measure their willingness to pay for all 5 donuts. So here, continuing with the example with donuts, we've changed the numbers a little bit, but notice now we're moving from 0 donuts to 5 donuts for the height of our trapezoid. So by here I mean the length along the horizontal axis. And then the two bases are identified. The first base is the length from 0 to 58, and the second length is from 0 to 37. So we would add up the 58 plus the 37, divide by 2, and multiply by 5, and get a total social benefit of the 5 donuts of $237.50. So here's one more example that's a little bit more algebraic and less graphical, but we could graph this example very easily, and I would recommend that you do it just so that you can see the calculations. So suppose the marginal social benefit is represented by the following function. So the marginal social benefit of getting Q is equal to 100 minus 2Q. The additional, i.e., the marginal social benefit of providing 1 unit of the good, So if let Q be equal to 1 in that equation, I would get a value of $998. And then we can ask the question, well, what's the total social benefit of providing 8 units? And then we could again calculate the area under the graph. So the total social benefit Q is equal to 8 units would be 1,000 plus 984, which is the height of the marginal social benefit curve where Q is equal to 8, divided by 2 times the number of units provided, which is 8. And we would get a value of $7,936. Okay, in summary, what we've just shown is the relationship between marginal social benefit and total social benefit. Total social benefit is the area of the region underneath a graph of the marginal social benefit curve. The next thing we'd like to do is to begin exploring theoretical connections between marginal social benefit and other economic concepts like demand and externalities.